Welcome students. In this video, we will be discussing about the time and space complexity analysis of displaying a linked list iteratively and also displaying a linked list recursively for both these concepts. Right? Fine. So coming to the time and the space complexity analysis. First of all, let us go for the time complexity analysis of creating a linked list. Right, we will do it for create, because creating is actually common for both your recursive approach and for your iterative approach. So first of all, let us find the time complexity of the provided creating a linked list. Okay, so let us take, for every operation we are going to take 1 unit of time. So coming here, for taking one pointer variable, allocating the memory for one pointer variable will be taking 1 unit. So for declaring two variables, let us consider we are going to take 2 unit of time. Okay. Then now allocating memory. Okay, allocating the memory here and allocating the memory and initializing to the first pointer. Let us take that it is going to take 1 unit. So one operation, 1 unit. Okay, fine. Suppose if you want to take that creating a memory block as 1 unit and assignment as a next unit, you can also feel free to take it as 2 unit. No issues. Right, because see, whatever time complexity that we are going to find is actually a approximation. It is not the accurate time. It is just a mathematical function that we are going to derive, which will tell you the growth of whenever there is a change in the input, how the time is going to increase. That increasing function only we are going to find, mathematical function. Right, so coming here, taking this variable x, we will have to take 1 unit of time. Then again, for scanf, let us take 1 unit of time, 1 unit. Then for assigning x to first of data, it will take 1 unit of time. Then assigning the address from first to last will be taking 1 unit of time. So every operation is going to be 1 unit. The next one, this is also 1 unit of time. The next scanf also will be taking us 1 unit of time. Okay, it also will be giving you 1 unit of time. And next, coming to the while loop, checking this condition x, how many times this condition will be checked? We do not know, because we do not know the size of the linked list that the user is going to provide. But let us assume that n, approximately some n will be the size of linked list. When some n is the size of the linked list, whatever is the size of the linked list, that many times this comparison will be taking place. Am I right or wrong? For example, you have taken 5 elements. Okay, one element already you inserted. Second element also you received outside. So second element you will be checking, first comparison, first checking. Third element you are comparing, second. Fourth element you will be comparing. Fifth element you will be comparing. And if the sixth element is -1, that also you will compare and then verify. So how many comparison will take place? 5 comparison will take place if it is 5 elements. So n comparisons will be taken. So n time if it is compared. One time if this is executed, 1 unit of time. If this line is executed for 5 times again, 5 unit of time. So if this line is going to be executed for n time, then it is going to be n unit of time. Okay. Then this loop is going to run for actually n unit of time. And what you can say, this creation of like allocating, creating a memory block in heap and assigning the base address to temp, I think this also will be taking n unit, because this line is not only one time it is executed, this is going to be executed for all the n times. So n unit of time. Next, this line, how many times executed? N unit it will be executed. So n unit time. Every line is going to be executed for n times inside while loop. So every line inside while loop is going to be executed for n times, so n unit respectively. So every line that we are taking it as n unit. Fine. The next is also going to be like n unit. Fine. Now, to find the time complexity of the entire program, let us add all the units together, all the unit time together. So for the create function, let me take t of n as the time function t of n is equal to add all the unit. Initially you're starting with unit, 2 unit. The next line is also 2. So 2 plus 2, 4. Then it is 1 plus 1 plus 1 plus 1. So 1, 2, 3, 4, 5, 6. So 6 already here, 2 plus 2, 4, 6 plus 4, 10. So 10 unit of time plus coming here. N unit, then again that's here also n unit. So 1, 2, 3, 4, 5, 6, 7. So 7n. So 7n, if you add together, you will be getting 7 multiplied by n. So 7n. So 10 plus 7n unit of time is completely taken. 10 plus 7n unit of time. This is actually a polynomial equation. For every polynomial equation, you will have a degree, highest degree. What is degree? Degree means if you have a variable, then whatever is in the power will be the degree. What is the degree of n here? N power 1. So here the degree is 1. Okay, degree is 1. So when the highest degree part only we have to be choosing. This is constant. Constant you can leave it aside. But coming here, this is the highest degree part having degree 1. Take the highest degree part, remove the constant, that is 7 is the constant, remove it. What is the remaining term that you have? Only n. So whatever is the highest degree, choose that term and remove the constant. Whatever is remaining, that you take it as time complexity. So order of n is the time complexity. What order of n is telling you? What is this function telling you? You can just take this simple function. What this mathematical function is telling you? This mathematical function implies that the growth is going to be linear. For example, if 5 input that you are trying to insert, then let me consider that 5 unit of time. If 10 input that you are trying to insert, then 10 unit of time. 15 input, 15 unit of time. 100 input, 100 unit of time. 200 input, 200 unit of time. So you have a linear incrementation. Whenever your input is increased, there is a linear incrementation in the unit time consumed also. I'm not telling that exactly whatever is the input size have to be the exact unit of time. For example, if for the input 10 it is taking 20 unit of time, okay, 20 unit of time, and for 20 it is like 15 unit of time. Okay, for 10, if input is 10, then for example let us consider 100 unit of time. If input is 20, then 110 unit of time. If input is 30, then 120 unit of time. So incrementation is actually in the linear phase actually. So when there is a change in the input, and if there is a linear increment in the unit time consumed, then it can be called as a linear time taking solution. So here create function comes under the category of order of n time complexity, which clearly says that it is a linear time complexity. So this is a linear time taking solution. This is a linear time taking solution. Fine. Now let us come to display function, iterative display function. Coming to iterative display function, how to find its time complexity? Okay, let us write the unit time taken by each and every line. Tell me how much time this condition could have been checked. I think for n plus 1 time, because for first node you could have checked it, second node checking, third node checking, fourth node checking, fifth node checking. Only 5 nodes we have, but I will move to sixth node, which is null, and I will also check that null also. So totally 6 comparisons I could have done if 5 nodes are available. So if n node is available, n plus 1 comparison done, because one comparison is for null, extra comparison. So totally how many unit? N plus 1 time if you are executing it, then n plus 1 unit of time. Then if condition is executed for n plus 1 unit, body part how many times? Because you are going to print only exactly how many number of element available. So how many number of element available? N number of element. So n unit of time will be taken for printing n element. So same, this temp equal to temp of next also, how many time this will be executed? N times. So n unit of time. So put together, what is going to be the time function here? T of n is equal to, add all these things together. You have 3n and 1 is available. So 3n plus 1 is the time taken. So this is a polynomial equation. What is the highest degree? 1 is the highest degree, and this is that term. And in this term, what we can do, we can neglect the constant term 3 and we can take it only n. So the time complexity can be order of n. So what is this kind of, this is a, what kind of solution? It is a linear time taking solution. Okay, fine. Now let us find the time complexity of this recursive function. To find the time complexity of recursive function, we have something called as recurrence relation. We will use recurrence relation. Let us consider this R display of temp as T of n, whereas n is the temp value. So let us take T of n, time function is T of n. Now tell us what this condition will be taking, 1 unit of time. Other than the recursive call, take 1 unit of time for all the other statement. So 1 unit of time. Here how much time it will be taking? 1 unit of time. Coming to this recursive call, let me tell you one thing. Initially, how much node you will be having? N node. Suppose first node if you are printing, and if you are going with the second node, how many node left you will be having? You will be having n minus 1 node. Total n node, 1 node you have printed. Next, how many node you will be having? You will be having n minus 1 node. So the same function we are calling again. So t is the function. Again, same t function we are calling, but not now there is no n node available. Only n minus node will be available. So we are taking it as t of n minus 1 unit of time. So this equation, you can add all these things together. So you will be getting t of n is equal to t of n minus 1 plus 1 plus 1, 2. This is called as recurrence relation. You know, mathematically you could have learned recurrence relation. When you take a recurrence relation, then automatically what should happen is that if you have a constant part, that constant part, whatever is the value, but you should change it to 1. Now what we will do is we'll just go to this online board and we will just start with that, solving that particular, recurrence relation. So t of n is equal to t of n minus 1 plus 1, and this time is actually taken if the condition is true. If the condition becomes false, when the condition will become false? When there is no other node available. When there is no node available, the condition will stop. When the condition is stopping, what you see, when the condition is failing, also you will be checking temp not equal to null, condition will be checked, but you will not enter inside. So when there is no other node is left to be printed, only checking process 1 unit of time will be taken. So for the base case, let me write the base case here. T of 0, 0 indicates that no node left. Initially n node we are taking, then we are changing it to n minus 1. But when it becomes 0 node, you can stop and only 1 unit of time you will be taking. How to solve it? With the help of successive substitution method. Coming to this successive substitution method, first of all, we should be finding the value of t of n minus 1. Okay, before that, let us consider the first equation. Let us consider the first equation as equation number 1. So this is equation number 1. Coming here, we have to find the value of t of n minus 1. Right? So finding the value of t of n minus 1 is equal to. So in the given equation 1, instead of n, if you substitute n minus 1, automatically you will be getting the answer of t of n minus 1. So instead of n, I have substituted n minus 1. Here also instead of n, start substituting n minus 1. So this will become t of n minus 1 instead of n, but there is one more minus 1 here. So minus 1 minus 1, this will become minus 2. So t of n minus 2 plus 1. Now let us take this equation as second equation. Now the next step that we need to carry out is that substitute the value, substitute the equation 2 in equation 1. So when you substitute the value of, when you substitute equation 2 in equation 1, now the new equation that we will be getting is t of n is equal to, so substituting the value of t of n minus 1. So instead of t of n minus 1, you can just provide t of n minus 2 plus 1 and there is one more 1 in the equation. So 1 plus 1, it will be equal to 2. And let this new equation be equation number 3. Let this be equation number 3. Now it is time for us to find the value of t of n minus 2. So find the value of t of n minus 2. So in the equation 1, instead of n, substitute n minus 2, you will be getting the answer. So t of, instead of n, if we substitute n minus 2, it will be n minus 2. Then again 1 minus 1 is there. So this will be n minus 3 plus 1. Let this equation be equation number 4. Now the next step that we will be doing is we will be substituting. So substitute equation 4 in equation 3. Substitute that in equation 3. Yes. Now what will be the new equation? T of n is equal to. So taking the value of t of n minus 2 and placing it here, this will become t of n minus 3, and there is plus 1 and here will plus 2. So totally it will be plus 3. And let us take this equation as equation 5. Now this will keep on going until when? Until there is no node is left. So when the node, so what we have to do is, first of all, we have to generalize this equation. How to generalize? So the next step is generalizing the equation. Generalizing the equation. How to generalize the equation? Yeah, I'll tell you. T of n is equal to t of n minus k. Why? What is that? Why is that I'm taking k? Because that is a value that is changing. Initially it was n minus 1, then it became n minus 2, then it became n minus 3. So it's a changing value. So that is going to be some random k. Generally we will take it as k. Then plus, this is also changing. But can you able to see that if this term is my 1, then this is actually 1. If this term is 2, then this term is also 2. When this term is 3, then this term is 3. So both are actually same. So if this is taken as k, then this plus term also should be taken as k. So this is the generalized equation. Let us take this equation as equation 6. And now this will keep on going. K value will be 1, 2, 3, 4, 5, 6. Keep on going. Until when? Until there is no node left to be printed. So 0. So this argument have to become 0. How that argument will become 0? That argument, that is n minus k, have to become 0. How it will become 0? This minus k, you can move it to the right side. So minus k will move plus k. So when your n is equal to k, if your n is equal to k, then automatically n minus k will be equal to 0. That's the only possibility. So now what you do is, instead of k, start substituting n value. So in equation 6, what will happen? T of n is equal to t of n minus n. So instead of k, we are substituting n plus n. So this equation, what we will be taking, this equation, let us take it as 7. Now, what this will, n minus n is equal to 0. What is t of 0? Answer of t of 0 is already 1 unit. So 1. So instead of t of 0, take 1. So the equation, final equation that we have obtained is 1 plus n. So what is the highest degree here? The highest degree is n power 1. Power 1 is the highest degree. So take that part alone. What is the part? N. Is it having any constant? No constant. So directly what you can write is the time complexity is actually equal to order of n. Okay. This is the time complexity of the recursive display function. With the help of recurrence relation, we have found it. Right? So now what I'm going to do is that, okay, let me tell you something. We will just write the time complexity. Okay, we will just write the time complexity of the iterative approach. Okay, so time complexity of iterative solution. Okay, iterative solution. Iterative solution is already we found that it is order of n, linear time taking solution. Then the time complexity, okay, time complexity of recursive solution is again order of n. So the time complexity of both the iterative method and the recursive method is same. There is no difference at all. So now let us differentiate the space complexity of both these things. Okay, so let us look at the iterative approach. Coming to the iterative approach, what are all the variables that we are having? Iterative approach, only one pointer variable called as temp we are having. So only one unit of space. So for every variable, for a single block, you will be taking 1 unit of space. So here, actually what you are having is, we are having only one variable, which means only one block we have. So one block means 1 unit of space. So the space complexity of the iterative solution, coming to the space complexity of iterative solution. When you look at the space complexity of iterative solution and the space complexity, we will just decide first of all. Let us take the space function s of n. It is equal to how many unit of space? Only 1 unit of space. 1 unit of space. So this is also a polynomial equation, but there is no variable like n. But we can manually insert, for example, 1 multiplied by n, but power 0, because n power 0 is equal to 1. 1 multiplied by 1 is equal to 1. So I'm just writing it in the format of, in the format of a polynomial equation. So what is the highest degree here? The highest degree is 0. The highest degree is 0. So take that highest degree part. N power 0 is the highest degree, right? So take that. So this is going to be order of n power 0. N power 0. So what is n power 0? Anything power 0 will always be 1. So the time complexity is going to be order of 1. What is this order of 1? This is said to be constant. If order of 1 can be time complexity, if order of 1 is time complexity, then it is called as constant time taking solution. If it is space complexity, then constant space. What is constant space? It means that what we mean by constant is that whatever is the change, whatever change that you face in the input, whether your input is 10 or 100 or 1 lakh or 10 crore or whatever your input is that, but your space is not going to change. Similar to coming to time complexity. If the time complexity is said to be order of 1, which means that whatever the input might be, 10, 100, 1000 or 10,000 or 1 lakh or 10 power 8 or something, but your time will not change. The same unit of time will be. For 10, for input 10 also 5 unit of time. 100 also, input 100 also 5 unit of time. 1000 also 5 unit of time. 1 lakh also 5 unit of time. Whatever the input is, but the output, the number of the unit of time that is going to be consumed is going to be 5 units. That is what we mean by constant. So the space complexity of the iterative approach is constant time taking. Okay. Let us come here. How many blocks that we are taking? How many blocks that we are taking in the recursive approach? I can just show you here how many blocks actually. Let me show you here. Can you able to see here? I think simultaneously we had how many activation record we were having? One activation, first node, second node, third node, fourth node. This is a node for null. So how many things? Totally n node for input. I mean n node for this n node is there, and one is for extra for null. So totally n plus 1 activation area. Can you able to see here? N plus 1 activation record created simultaneously, same time. So when this n plus 1 activation area, each and every activation area, you have one block. So n plus 1 activation area, every activation area is having one block. So totally how many blocks created? N plus 1 block created. Totally n plus 1 block created. So for every block, 1 unit. So n plus 1 block, n plus 1 unit of space. So the space complexity, let me come here to the space complexity thing. So coming here to the space complexity of the recursive approach. The space complexity of recursive, okay, of recursive solution, okay, of recursive solution is equal to space function is equal to how many blocks that you have taken? N plus 1 block. So n plus 1 unit of time. Coming here, what's the highest degree? N power 1. Here n power 1 is the highest degree. So you can take it as order of n. So what is the space complexity of your recursive approach? It is a linear space. Linear space. So if your input is 10, then 10 unit of space. 10 block. If 20 is the input, 20 block. 1000 is the input, 1000 block. 1 lakh is the input, 1 lakh block. Okay, so space complexity of the recursive solution is order of n, where the space complexity of the iterative is order of 1. Now compare the iterative solution and recursive solution, which will become the efficient one. I think comparatively, iterative solution is efficient because iterative solution, it is order of n, recursive also order of n, so time complexity balanced. But coming to the space complexity, clearly iterative solution winning it. So put together, we can say that space complexity, because of the space complexity, iterative solution is clearly winning in this particular, concept. Not every time, but here in this particular concept, recursive approach is not winning the game. Iterative approach is winning the game. Yes. Okay. So time complexity and the space complexity of both iterative and the recursive approach have been successfully discussed here. Right. So what we can do is that we can just meet in the next video. Okay, hope to meet you in the next video. Thank you, students.